is Matt Edson, and today I'll be discussing mathematics strategies. Prerequisite skills are needed before these strategies will fully affect the students. First prerequisite math skill that the students need to have a grasp on is number sense. This is the fluidity and flexibility with numbers. They must understand the basic math concepts, able to learn more advanced mathematics, understand numbers have meaning, the relationship between numbers, the magnitude of numbers, operations of numbers, understand that numbers measure items in the real world, and have counting skills. Another prerequisite math skill is basic mathematic principles. Principles include place value, which is the basic value in the placement of a number that gives the number a value, expanded notation, showing the value of each digit, commutative property, how numbers are placed in a problem, associative property, add or multiply no matter how the numbers are arranged, distributive property, ability to change numbers within a problem and end with the same result, equivalence, one part can be equal, the other part divided by an equal sign. Another prerequisite math skill, students need to have the basic fact rules in mathematics of operations of addition, subtraction, multiplication, and division. Granted, teaching a subtraction strategy, the student would need to understand that basic fact rules in order to understand the subtraction aspect of the strategy. The first strategy that I'd like to teach you today is called chunking strategies with peg-word mnemonics. Chunking is a natural ability used by the brain. Donna K. Wood and Alan R. Frank used chunking to help students learn multiplication facts. They had teachers leave comments for them about the success students were having with this strategy. The student developed a positive and enthusiastic attitude toward math instruction. They not only reported enjoying math more, but attributed their learning success directly to the mnemonics method of materials being taught. Despite daily medication for ADHD, they exhibited attention deficits in the academic area. However, a change in task completion occurred during mnemonic instruction, and those are both from Wood and Frank 2000. All right, looking at this chunking strategy with peg-word mnemonics, first we look at the 0, 1, 2, 5, and 9 chunking strategy rules. We understand that 0, you look for a 0. If you find the answer, if you find it in the question, the answer is 0. Simple enough. Number 1, you look for a 1. If you find it, ignore the 1. Cross it out. The answer is the other number. 2. Look for 2. If you find it, ignore the 2. Look at the other number. Remember the double pictures for that number. There are peg-word mnemonics that are double pictures that students can refer to, or you can have them refer to their addition and have them plus the same number together. 5. Look for 5. If you find it, ignore the 5. Look at the other number. Count by 5s that many times. And 9, look for 9. If you find it, ignore the 9, look at the other number. Subtract 1 from the number, put the answer in the tens place, look at the link to the number at ones place. All right, before I show examples, here is the nines place, the links that I would like to show you. That 1 and 8 go together, 2 and 7 go together, 3 and 6 go together, 4 and 5 go together. This is also a nice graphic that shows 0, 1, 2, 5, and 9, and it gives you the strategy for each number. Now let's look at some examples for these numbers. First, let's look at 0. 0 times 6 equals what? All right, so I know that the strategy is look for 0. If I find it, it is the answer. Looking for 0, oh, there's a 0. The answer must be 0. 1. 1 times 7 equals Okay, so I'm looking for a 1. I found a 1. So then the other number is 7, so that is the answer. So 7. 1 times 7 is 7. 2. 2 times 4 equals, so looking for a 2. Okay, I found a 2 here. So I'm going to circle that 2. If you find it, ignore the 2, look at the other number. All right, 4. So I'm remembering the double pictures of 4. If I don't have that, if I'm not equipped with that quite yet, I can look at 4 plus 4, and that is 8. Looking at 5. 5 times 7 equals what? Look for 5. Okay, I found 5. There's a 5 right here. If you find it, ignore the 5. I'm going to ignore the 5. Okay, now I got to count by 5s 7 times. I can use my hands, or if I'm good with by 5s, I could use mental. 5, 10, 15, 20, 25, 30, 35. 35 is my answer. That is 7 times. The last one, 9s. 9 times 6 equals, well, it says look at 9. If you find a 9, ignore it. So I find a 9 and I ignore it. Subtract 1 from 6. Okay, so that's 5, and I put that in the tens place. Then I look at my links, which 5 and 4 are links together. So 9 times 6 is 54. These cover 0, 1, 2, 5, and 9. Let's go ahead and move on. And here's the link list of strategies. That is a good reference point and has some examples on the side for you. Now looking at the chunking strategy with the peg word mnemonics. Peg words are mnemonics that students use to help their memory. Most of the time they are rhyming. So before teaching the peg words, have students associate numbers with a rhyming peg word. Here is the chart that you would need to use to find your peg words. As you see, number 1, sun, symbol of a sun. 2, shoe, picture of a shoe. 3, tree, picture of a tree. There's also numbers such as 18, baiting, and a picture of baiting, and 12, elf, which is an elf. Also, there's a note on here that twin T symbol refers to a popular TV called Mr. T, who had his head shaved except for a strip on the top of the head. I'm a little young for this, but I do refer to Mr. T as seeing him in some commercials in his later years, so I can refer to twin T as Mr. T. Going back to the chunking strategy with peg word mnemonics, before beginning, the teacher will begin teaching these peg words by doing multiple days of instruction. And depending on the age of the students, this could take 1 to 2 weeks. First, the teacher will prepare flashcards, one side of a number, on the other side the peg word and its symbol. Then they will take 1, 2, or 3, depending on the age of your students, and you will have them memorize those pictures with numbers. They will have practice these sessions daily and continue to add more flashcards as you go. I would recommend adding 1 or 2 to start, adding another one, and continuing and keeping them all in until you get every peg word. After students get the groups of numbers, their peg words and symbol, the teacher prepare flashcards that combine the peg words. So once then, you combine the peg words for the same multiplication problems. Like 3 times 4, you would combine tree and door and show that it equals an elf on the other side. Once students understand these concepts, being the peg word strategy, you can move on, and that'll help you understand these multiplication problems that don't apply to 0, 1, 2, 5, and 9. Wood and Frank stated that the instructional method will teach you students how to approach multiplication facts rather than relying on roll memorization. Also, the elimination of calculators and multiplication charts is a key factor in this chunking and peg word strategy. Here is a peg word and symbols worksheet that would be shared with your students, and you would get your reference from. And this is from Wood and Franks 2000 once again. Example problems. 3 times 3 equals 9. So I'm looking for tree and tree on a line. So the students would know that tree and tree on a line. So they would look and see tree and tree on a line. That means 3 times 3 is 9. The next one, 3 times 4. 3 times 4. So that's tree with a door. So what comes out of a tree with a door? I think of the cookies, elf. So tree with a door for an elf. 3 times 6. Tree times sticks. Tree times sticks are baiting is the saying. So tree times sticks are baiting. So 3 times 6 is 18. Next one, 3 times 7. Tree times heaven by a twin T sun. So we know that 3 times 7 is 21. 3 times 8, tree on a gate to a twin T door. So twin on a gate, 20 door. 4 times 4, door and door are mixing. So door and door are mixing, which would be 16. 4 times 6, door and sticks by a twin T door. So 4 times 6 is 24. This is not all of the numbers that work for peg words, and you will need a bit of time to study these peg words and their pictures to better understand these problems. Next, we're going to look at process mnemonics. This is a strategy used that incorporates silent stories and characterizations that help with memory of rules of procedures. The study done in 2000 examined 29 13 and 14-year-old students. The impact of the process of mnemonics through the evaluation of students on a pre and post test on a scale of 1 to 10. The students using process mnemonics gained 6.88. The students who used DI instruction gained 4.29. The placebo instruction, which is a instruction that doesn't really teach the concept, the students were negative 0.57, and the students who received no instruction on the concept, negative 0.33. Process mnemonics are improved the overall instruction in the classroom, gave students the opportunity to talk with another more frequently about the subtraction problems. We're going to look at process mnemonics in the subtraction, the setup. This silent story refers to warriors fighting. So I would say this would be something that maybe would be an elementary learners, or students who enjoy fighting, which are, you could refer this to video games and stuff like that. So first, two numbers are two sets of warriors fighting each other. Digits indicate their strength. So we're going to refer to this slide here. So we have two digits, 8715 and 6907. Now, warriors had a decimal point is designated which warrior was ranked higher. Okay, so each of these have decimal points. So the 87 is ranked higher than the 69. So the 87 would be on top. Digits to the left were ranked warriors, while those to the right were unranked warriors did the same. After numbers have been lined up, top and bottom were assigned attackers and defenders. So they're lined up, the attackers and the defenders. Okay, so that was the setup. Now we're going to move on to the method. Imagine that the attackers were trying to get past the defenders so they could pass through the subtraction line. Okay, so this is the subtraction line. These attackers are attacking the defenders, and they need to get through the line. When they battled, the attackers lost some of their numbers value. Keynote: when they're regrouping, warrior strengths lower from the opposite defending warrior's strength. First, increase the attacking warrior strength by 10. This enables the attacking warrior to get past the strength defender. So, if the warrior, like in this example, the 5 is not higher than the 7, then we have to add 10 to it to make it 15. That makes it stronger so that it can attack the 7. But to the left, the attacker to the left actually loses 1, so he goes to 0. Then, like I stated, the consequence of the increase attacking by 10, the other one gets 0. So now we have the attack of the defenders. So we have 587.15 minus 69.07. 5 does not subtract from 7 because 5 is smaller than 7. So we take it from the 1. That makes that a 0 because we have to take the 1 away and add 10 to it. 15 minus 7 is 8. 0 minus 0 is 0. 7, 9. 9 is higher than 7, so I have to take 1, make the warriors weaker to the left, which is a 7. Then I have to add 10 to the attackers, so that makes 17. 17 minus 9 is 8, and 7 minus 6 is 1. That would be the process mnemonics warrior strategy. Let's go ahead and look at another example. Sorry, we had a little, still the last slide on there. Get rid of that real quick. All right, so we're looking at a warrior problem of subtraction. We're going to first say we're going to have 74.18, and we're going to have minus 73.25. It's minus, and they're getting through that sign. All right, so we need to know that the top is the attackers, the bottom is the defenders. So 8 minus 5. So the 8 is attacking the 5, so 8 minus 5 is 3. And remember, this is a strategy that helps students remember the process of subtraction. Next, we have the 1 minus the 2. 2 is bigger than the 1, so that means that we have to take 1 away from the 4, which is 3, and add 10 to the 1, which is 11. So 11 minus 2 is 9. The 3 minus 3 is 0. And 7 minus 7 is 0. So the answer is 0.93. Remember that we're having attackers attack the defenders, and it gets us, they got to get through the line of battle in order to successfully win the competition. The last strategy that I would like to discuss is diagrams. And everybody uses diagrams in different ways and in many different subjects. I can think of using diagrams in science, social studies, English. Diagrams have been proven to be effective guides for problem solving in mathematics too. This study that I examined was 125 8th graders with 4 mathematic word problems that were different in their story, context, and structure. They examined the use of the diagram during these word problems. So the study was the use of the diagrams to see how many students used the diagram to help them get the problem correct. As seen, when it was a long story problem, 70% of the students used the diagram and successfully completed the correct answer, while a short story problem, only 35% of the students used the diagram to get the correct answer. The other percent chose not to use the diagram or did not get it correct. The study found that the length of the story problem factors the amount of the word problems, while amount of change is more spontaneous with the use of the diagrams. A diagram can consist of a graph, a table, or a drawing of any sorts. So we had a word problem here. This is the example of a diagram. Jimmy's mom went to the store and bought 9 oranges, 7 apples, 8 bananas, and 6 kiwis. When they got home, Jimmy dropped a sack full of fruit. 1 orange, 4 apples, and 3 kiwis were smashed. How many pieces of each fruit did Jimmy have left? All right, so what we did here was we made a table of oranges, apples, bananas, and kiwis. We put how many we bought minus how many we smashed. So oranges was 9 minus 1 was 8. Apples 7 minus 4 is 3. Bananas 8 minus 0 is 8. And kiwis 6 minus 3 is 3. So we found out that oranges had 8 left, apples had 3, bananas had 8, kiwi had 3. A simple diagram of like a table that is created here is a way that students can organize the information of a story problem, get all the words out of the problem, and just have the numbers. Once they have the numbers, then they can use their multiplication, division, subtraction, or addition that they know and understand to solve the problem. You can also use graphs, or just a sketch would be another way to solve this problem. Here are my references for today's presentation. Thank you for joining me today on Mathematics Strategies.